All right, we're continuing to look at solving quadratic equations. A quadratic equation, again, is whenever you have an x squared inside of a problem. Now, you could solve it with just x squared, but the problem really comes in when we have x squared and x, and that's what we've been looking at. Right now, we've been working on how to solve it using the zero product property and factoring. And that's what we're going to review here in the first part. 88A was a homework problem. I did modify this a little bit. They had x squared. They had the 40 on the left side. I'm just going to show you what it looks like here when it's not in standard form. Let's go ahead and review. All right, first thing we want to do is get it in standard form. Subtract that 40 from each side because we want to have x squared plus 6x minus 40 all on one side. We need it to equal 0 on the other side. That's so that we can apply the zero product property. We're going to need the product to be 0. In order to get a product, I have to change this trinomial into two binomials that are being multiplied together. We do that by factoring. I notice it's just x squared goes down to x and x, which multiplies to get negative 40, but adds to get 6. And if you think that through, we find that 10 times negative 4 works. So it's going to be x plus 10, x minus 4. That's our just x squared shortcut. So that product is equal to 0, meaning that x plus 10 could equal 0. Or x minus 4 could equal 0. If you need more practice on this process here, go back and watch my other video and get some more practice on it. Right now, this is just a review. We find that x could be negative 10, and here we see that x could be 4. And again, you could probably see that without writing out that work, and that's okay. But we find here x is negative 10 or 4. All right, so let's try the process over here in this next one. All right, it is in standard form already, so that's good. And I'm going to go ahead and start by factoring. I see that it's just x squared, so again, it goes down to x and x. What multiplies in this case to get negative 7, but adds to get negative 3? Well, negative 7, it's going to be a negative and a positive, and the only options would be negative 7 and positive 1, but those would add together to get me a negative 6. So that won't work. If I do a positive 7 and a negative 1, then I'm going to get a positive 6. So either way, we find out this one is not factorable. Which, at that point, you might be thinking to yourself, well, then there's no solution. And you might just go, hey, x equals null and no solution. And you think, hey, that's it. But that would mean that this has no roots. Again, if we look at this as we look like y was put in here, that means that this parabola, when graphed, would never cross the x-axis. And maybe that's true. But let's take a look for a moment and see if that is true. Here we go. We've got the equation. Here it's y equals x squared minus 3x minus 7. And if y is 0, that's where we're looking for the x-intercepts. That's right here and here. Notice y is 0. And I see here that we've got 2 points. We see that there are x values that make this true. Something's unique about these points, though. We see here that this is not a nice whole number. In fact, that's actually a rounded decimal. These are irrational. These are irrational values of x, which we could not get there by factoring. And that's the problem that we run into. So we have to find a way to solve this equation without factoring, because there are answers. This is not true. It is solvable. There is a solution here. We just don't know what it is. And that's where the quadratic formula comes in. There's a quadratic formula. This was derived from a process of factoring this standard form of a quadratic equation with all variables. They factored it with all variables using a process called completing the square. If you're interested in seeing that, I'll show that to you at a later time, maybe in a later video. But right now, you just need to know that this is a formula. This formula works. Every single time you've got a equation and a quadratic equation here in standard form, that is that it's already set equal to 0, then the coefficient of x squared is a, the coefficient of x is b, and the constant is c. And if you take those numbers and plug them into our formula, into the spots where they belong, and then you just follow your order of operations and simplify that, you will find the value of x that makes that equation true. Let's take a look at some examples. All right, so here we go. Back to the one that we were just looking at. We saw this one is possible to find a value of x. We just couldn't do it via factoring. So what I'm going to do is I'm going to start by writing a equals b equals c equals, because it's in standard form, and I'm going to identify a, which in this case is 1. b, which in this case is negative 3. Do not forget that negative. And c, which is negative 7. Then I'm going to use my quadratic formula over here, and I'm going to plug in the values where they go. The first up is negative b. That means the opposite of b. In this case, b is negative 3, so negative 3, in other words, the opposite of negative 3 would be 3. Plus or minus, I'll talk about what that plus or minus means in a moment. The square root of, use parentheses here, negative 3 squared. Notice the negative 3 is inside parentheses, squared is outside. Be careful. In our evaluate expressions, we dealt with that heavily, and that would be a common mistake. Times 4, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, which is 1. What I want you to do, first off, is I want you to simplify this here that's underneath the square root. Get that all down to one number and simplify this one down here. That's going to be easy. 2 times 1 is just 2. All right? So when we do that, my next step, I'm going to put 3 plus or minus the square root over. And then I want you to simplify those. If we simplify that top one and you plug that into your calculator exactly as is from one parenthesis to the other, you find that you get 37. Notice 37 is not a perfect square number. The square root of 37 is an irrational decimal, and that's where our rational answer is going to come from. And 2 times 1 on the bottom is just 2. Now, in your calculator at this point, I encourage you, we got to get 2 answers. There are 2 routes here. One that is a plus, where x is going to equal 3 plus the square root of 37, then divide by 2. And the other answer, there are 2 answers here, just like we saw, 2 roots, 2 spots where it crosses the x-axis. All right, and the other is going to be 3 minus the square root of 37 over 2. Plug those into your calculators. I would encourage you to do this. In your calculator, type 3 plus square root 37, and then hit the equals button to make sure that those are added first before you hit the divide by 2 and then equals again. Okay, that's what I'd recommend punching into your calculator. You do the same thing for the other one. You'll do 3 and then hit minus square root 37, and then hit the equals button before you go ahead and then hit divide by 2 and then equals again. That'll give us our 2 answers in this case. And in this case here, we find that when you do that, you find that x is, well, sorry, I'm not going to use equals. I'm going to use this little symbol here, approximately, because I'm going to round. We are rounding our values here. We find that in this case, x is approximately 4.5 and negative 1.5. And if we go back to our spots here, we see that that's actually true. Technically, we got negative 1.541, and it kept going forever and never repeating. Just round that to negative 1.5. If you want to go to 2 decimal places, you can. And the other one to 4.5. Okay? So that's approximately the values of x that make this equation true. And that's how we're going to solve quadratic equations that cannot be factored but still have an answer. Let's take a look at a few more examples. Let's take a look at this one. Once again, start with A, B, C. All right, and we're going to identify A, in this case, is 3, B is 7, and C is 2. And so we plug those in. X equals the opposite of B, negative B, so in this case, negative 7, plus or minus the square root of 7 squared minus 4 times A, which is 3, times C, which is 2, all over 2 times A, which is 3. And I want you to simplify this down to negative 7 plus or minus the square root of one number all over another number. And take your calculator right now, and I want you to plug in from this parenthesis here all the way over to that parenthesis. Go ahead and do that, and then we'll see what we get. All right, and you should have gotten 25. And on the bottom, 2 times 3 is 6. Now, one thing I want to point out about this 25, all right, right here, we see that that is a perfect square number. In fact, the square root of 25 is 5. And so we're going to actually be able to take its square root. That means that this original trinomial was factorable. All right, you could have factored it. I'll do that in a little side note over here. But we could have factored it going 3x squared, 2. What multiplies to get 3 times 2 is 6, and adds to get 7, 6 and 1. That right there tells you that it is factorable. You could complete that diamond problem. You could plug in 6x, you could plug in 1x, and you could pull out a GCF. And you could actually get x plus 2 times 3x plus 1. You could have set that equal to 0, and you could have used the zero product property at that point to solve it, finding that x could be negative 2 in this case, and here x could be negative 1/3. All right? So this was factorable, but that's what the 25 tells us. It also shows us that you can use the quadratic formula anytime. So let's go ahead and let's finish this out here. Well, that means that x is going to be negative 7 plus or minus 5 over 6, and therefore x could equal, and I'm giving an equal sign this time because it's not an irrational answer. I could take the square root of 25. So I'm going to get negative 7 minus 5 is negative 12, and negative 12 divided by 6 is negative 2. All right. I'm also going to do negative 7 plus 5, which gives me negative 2. Negative 2 over 6 reduces down to negative 1/3. Notice those are the exact same answers that we would have gotten if we factored there. Quadratic formula can be used anytime. Some of you will really like it for that. Let's take a look at another example. All right, this one here. Now, all of a sudden, we find that a equals 1, coming from right there in front of the x squared. B equals negative 5. And c equals 9. All right, so let's plug those in. X equals the opposite of b. B here was negative 5, so I'm just going to put in a positive 5. Plus or minus the square root of negative 5 squared minus 4 times 1 times 9, all over 2a, 2 times 1. And go ahead and let's boil that down to 5 plus or minus the square root over, and get that square root down to one number inside there, and do the bottom. The bottom's easy to do in this case. 2 times 1 is 2. Take your calculator and do the top. All right, and when you did underneath that square root, you should have gotten negative 11. All right, some flags should be going off right now, because what is the square root of negative 11? If you don't know, try to type it into your calculator. See what happens. All right, you'll find you get an error. You cannot take the square root of a negative number. That's because it's asking what multiplies by itself to get negative 11. Well, just think about it. 2 times 2 is 4, positive 4. And negative 2 times negative 2 is also positive 4. Anytime you square something, whether it's negative 2 squared or whether you square positive, you always get a positive number. Therefore, we can't take the square root of a negative. That is going to give us an impossible, an imaginary number. That's the point where we realize this one has no solution. So at that point, if we take a look at the equation, well, over here, I take that equation, x squared minus 5x plus 9, put it on. Notice, does it cross my x-axis at all? No, it has no point where it touches my x-axis. That's why there's no value of x that will make y equal to 0. There's no value of x that will ever make this true. In fact, there's no value of x that will make any of these values down below that vertex true. None of these values here are ever going to be possible. The parabola just doesn't go down there. Therefore, we declare no solution, and this one is complete.